This is Module 8, Sports Science. To start off, I'll go through all the physics that we've gone over so far. First off is we learned velocity, which is displacement over time or distance over a set amount of time. Symbol is V. SI unit is m over s or meters per second, and the formula is delta d over t, or change in distance or displacement over time. And then in Module 2, we learned acceleration. Acceleration is defined as the change in velocity per unit of time, and it must have an acceleration, positive or negative. The symbol is A. SI unit is m over s squared, meters per second squared, or meters over second, meters per second squared. And the formula is change of v over t, or final velocity minus initial velocity over time. And then we have force, which is defined as a push or a pull or force. Symbol is an F. SI unit is N, or newtons, and the formula is F equals ma, or force equals mass times acceleration. Work is defined as force applied over a distance. The symbol is a W. SI unit is J, or joules, and the formula is W equals F times delta D, or force times change in distance. And then finally, we have power. That's defined as rate at which work is done. The symbol is P. The SI unit is W, or watts, and the formula is defined as W over delta T, or work divided by change of time. So for my story problem, I took the 5 fundamental things of physics, what we've gone over so far, which is velocity, acceleration, force, work, and power, and I applied it to me skipping over the distance of 100 feet. Speed skipping is actually a sport, I guess I put it out. So first off, for our first set, we did velocity, which is d over t again. So I skipped over a distance of 100 feet, and that turned out to be 30.48 meters. And so 30.48 meters divided by my time to skip that distance, which is 6.74 seconds, turned out to be 4.522. And then don't forget labeling, meters per second. Next, we have acceleration. So for acceleration, we actually take our final velocity, which we got in our previous velocity set, which was 4.522 meters per second, minus our initial velocity, which was 0, because we were at a still point, divided by t, or time, which was 6.74 seconds, and that calculated out to be 0.671 meters per second squared. And then I found force. So the force I applied skipping over that distance of 100 feet, or 30.48 meters. So first I had to find all the variables in force, starting with mass. So I weighed myself, and I was 165 pounds, and that calculated out to be, well, that translates out to be 74.84 kilograms. And so I plugged it into the F equals ma equation. So 74.84 times 0.671 equals 50.217 N, or 50.217 newtons. So that was my force. Next, I found work. Again, work is defined as F times delta T, force times change in distance. And so I took all of my variables I found previously. So we found that, yeah. So to find work, I took what we just found, which was force 50.217 newtons times the distance, 100 feet again, turns out to be 30.48 meters, and that gives us 1,530.614 joules. And lastly, we found power. Actually, to find power, we had to go through all four previous calculations, and we actually had to find all four physics terms, or before we find all four. We had to find all four physics answers. That was velocity, acceleration, force, work, and now we're finally at power. So this is our fifth and final set, and it's defined as, again, W over delta T, or work divided by change of time. And again, previously we just found out what work was, which ended up to be 1,530.614 joules. And we divide that by our change in time, which again was 6.74 seconds, which was the time it took to skip the 30.48 meters. And that calculated out to be 227.094 watts.